I know, it looks mad, and it definitely will look crazier if you didn't watch my first video on chemical formula. Click on that video on the top right hand corner, okay? But at the end of this video, you will understand where these big numbers came from and why we now consider this equation balanced. But where are my manners? It's Uncle Jegs here. Let's get started. This sentence here tells us what's happening in this simple chemical reaction. It's saying that hydrogen reacts with oxygen to form water. And we can write this as a simple equation like this. There are several simple chemicals that you need to memorize, but I'm going to save that for another video. Let's concentrate on balancing equation in this video. When you're getting started balancing equation, I recommend you actually thinking of these equations in terms of the particles that make up the equation. There is a small 2 on the right hand side of the H. This means that we've got 2 atoms of hydrogen within that one molecule. The same is true for the oxygen. We've got a 2 on the right hand side, so we've got 2 oxygen atoms bonded together in that one molecule. For the water, on the other hand, we've got 2 hydrogens and an oxygen bonded together. When you have just one atom of a specific element, you don't have to write the one next to it. Notice how this is done in water. We've got 2 hydrogens, so it's H2, but we don't have O1. We just leave out the 1. Looking at the particles themselves, we can see that we've got an equal amount of hydrogen on the reactants on the left hand side and on the products on the right hand side. But we are missing 1 oxygen on the right hand side because we've got 2 on the left, the reactant side, and only 1 on the right hand side, the product. So this equation clearly is not balanced. And in order to balance equations, we need to either add or remove big numbers in front of the molecules. We don't change the small numbers. We're only adding or removing big numbers in front of the molecule. First thing you should do whenever you're balancing equations is to draw a line underneath where your arrow is. And on both sides, we're going to tally up the number of each element that we have. So on the reactant side, we have 2 hydrogens and 2 oxygens, but on the product side, we've got 2 hydrogens, but only 1 oxygen. This means that we need to add oxygens onto the product side somehow. Remember that you only change the reaction by either adding or removing big numbers in front of your molecule. We don't change the small numbers, okay? So let's start by first adding a big 2 in front of the water. So now we've got 2H2O. What this means, as you can see with the diagram, is that we've got 2 molecules of water now. But this also means that we've changed the number of hydrogens that we have. So let's show that in the tally below. So we cross out the 2 hydrogens that we had in the tally. So we've got 2 times 2 hydrogens, which is now 4 hydrogens. And now we've got 2 times 1 oxygen. So we have 2 oxygens now. Okay, so the oxygen is balanced, but we've also now changed the hydrogen. Should probably be able to work out what we need to do now. We need to go back to the reactant side and now balance the hydrogens. So we put a big 2 in front of the hydrogen molecules. So now we've got 2 times 2 hydrogens, which gives us 4 hydrogens. And let's look at our equation. We've got 4 lots of hydrogens on both sides and 2 lots of oxygens on both sides. And if you look at the diagrams as well, the equation is balanced. This is why it's important to tally your elements, especially when you're new to balancing equations. It helps you track how many atoms you've got on the reactant side and on the product side. And if it's still a little bit too abstract for you, you may want to draw out the molecules as well. It doesn't matter how you draw out the shape, as long as you've got the correct number of atoms in each molecule or formula. That's all that matters, okay? You don't need to draw out the atoms if you're confident. All you need to do is just draw the line and tally up your elements and then start balancing by adding big numbers in front of the molecules. We have 2 hydrogens and 2 chlorines on the reactant side and only 1 of each on the product side. What we need to do is just one straight move. We put a big 2 in front of the HCl to give us 2 hydrogens and 2 chlorines on the right hand side. And now the reaction is balanced. Now look at this example. Try and work this one out yourself. I'll give you a hint for this one. You don't necessarily need to have your big numbers in front as whole numbers. You can have something and a half, so you can have 1.5, 2.5, 3.5, etc. On the reactant side, we have 1 phosphorus and 2 oxygens. On the right hand side, the product side, we have 2 phosphorus and 3 oxygen atoms. A good rule of thumb whenever you have oxygen molecules by themselves is to balance the oxygen last, okay? So let's first balance the phosphorus. We need to add a big 2 on the left-hand side in the reactant side. So now we've got 2 phosphorus on the reactant side. And there are 2 things you could have done here. The simplest thing you could have done is to just times your oxygen molecule, which is 2 oxygens together. You can times that by 1.5 to give you 3 oxygens on the left-hand side as well. So that's what I've done here. I've times it by 1.5 molecules, which gives us 3 oxygen atoms on the left-hand side. But you can also work it out in a way where you've got whole numbers. That just means you have to times everything by 2. So we'll have 4 phosphorus, we'll have 3 molecules of oxygen, and then we have 2 molecules of phosphorus oxide. Now let's look at the example we had at the start of the video. Try have a go at this one, okay? It's multiple steps, but I'm sure you can work it out. First, we start by tallying our elements. On the reactant side, we have 1 copper and 1 aluminium. Notice that the nitrate on the left-hand side, on the reactant side, has 2 lots of that nitrate ion. So everything within the bracket, we have to times by 2. So we have 2 nitrogens and we have 6 oxygens. On the product side, we also have 1 aluminium and 1 copper, but the nitrate now has been multiplied by 3. So everything within the nitrate has been multiplied by 3. So we have 3 nitrogens and 9 oxygens. So far, so good? Whenever you get a situation like this, what I recommend is looking at what you've multiplied your nitrates or your polyatomic ions by and swap the numbers on either side. So we've got a 3 for the nitrate on the product side. So what we're going to do is that we're going to transfer that 3 over to the reactant side. But remember, it's a big number that we'll put in front. And the same for the reactant side as well. We have a 2 on the reactant side, so we're going to transfer that over to the product side. Let's see what that looks like. The 3 that we transferred over to the reactant side means now we have 3 times 1 copper, we have 6 nitrogens, and we have 18 oxygens. The 2 that we transferred over to the product side means we now have 2 aluminium atoms, we have 6 nitrogens, and 18 oxygens. So the nitrate is balanced. You can probably work out what we need to do now. We just have to balance out the metals. So we need 3 lots of copper on the right hand side and we need 2 lots of aluminium on the left hand side. And there you have it. That's how we balance equations. With stuff like this, it's a skill. So the more practice you have, the better you become. But that is the basics of what you need to do. Next lesson, we're going to be looking at relative formula masses. So like and subscribe if you like what you saw. Comment below if you're baffled about something. And I'll catch you guys next week. Take care.